Good afternoon, everyone. So, my this topic is 8051 microcontroller. So, before studying microcontroller, we have to see what is microprocessor and what is difference between microprocessor and microcontroller. So, microprocessor is called as general purpose microprocessor. This means this microprocessor is used for any general purpose where processing is required. So in microprocessor, if we need to connect memories, IO port, timer, serial ports, this has to be connected externally on a motherboard, right? So we have to use different chips for each component on the motherboard. But in case of microcontroller, if we see memory, IO port, timer, serial ports, all these components are mentioned on a small 8051 or any microcontroller chip itself, right? So all these components will be on same chip. So we have studied the difference between microprocessor and microcontroller. In microprocessor, RAM, ROM, IO, timer, serial ports have to be connected separately. Whereas in case of microcontroller, RAM, CPU, IO, timer, right? So all will be on single same chip. Microprocessor we are using for any general purposes, whereas microcontroller will be used for any specific function, for any specific application. That can be any of application, right? So then we have to study this block diagram of 8051. So 8051 is a 8-bit microcontroller. So 8-bit means at a time it can process on 8-bit of data. 8051 now is having a two memories, ROM and RAM. ROM is called as program memory. This will be used to store the permanent data, where RAM is data memory, will be used to store the data temporarily. Then serial port is used to transmit and receive the data serially. Two timers are used in 8051 and each timer will be of 16-bit. Timer is used to give the delay in the program. So then we are having a 4 IO ports. IO is input output device, right? So input output interfacing can be done using these 4 ports. Each port is having a 8 pins. So then we have to study the features of 8051 microcontroller. So if we see processor is of 8-bit ALU, 4 kilobyte of ROM is required, 128 byte RAM, external ROM and RAM both is of 64 kilobits. Two timers are used, each timer is of 16-bit. Then we are using 4 IO ports. Each port is having 8 lines and all the lines are bit addressable. 2 serial ports are used for transmission and receivement of serial data. So this is the same modified block diagram. If we see 4 IO ports, each port is having 8 lines. So these ports are from P0, P1, P2, P3. This is a serial port, timer, internal RAM, internal ROM. Oscillator is used to produce the frequency for the processor. Then interrupt is used, external and the internal interrupts are used in 8051 as other microprocessor chips. So this is the pin diagram of 8051. 8051 is having 4 ports. Port 0, port 1, port 2 and port 3. All ports behave as an alternate function. Alternate function is if it is not used as an IO port, it will be used as any other alternate function. Port 0 is used for address and data buses. This means if port 0 is not used as an input and output, right pin, then it has to be used for address and data bus. Clear? It can be used as an address and data bus. So this will be decided by ALE function. ALE is address latch enable. If ALE is equal to 1, so this means the port 0 pins will behave as an address bus, right? And AL is equal to 0, then the line on port 0 will be used as a data bus, right? Address bus is used to locate the location in memory's location from where the data has to be fetched, whereas data bus is used to fetch the data from that location. Now port 1 is you behave as the only IO ports, whereas port 2 is used as an address bus. As we know, address bus is of 16-bit. And 8051 is a 8-bit microcontroller. So data bus will be of 8-bit. So higher byte will be used on the port 2, whereas lower byte will be used on port 0. Then port 3, if we see, alternate functions are given. Pin number 0 and 1 at port 3 will be used to transmit and receive the data serially. Pin number 2 and 3 will be used on port 3 for the interrupt signals. Pin number 4 and 5 will be used on timer. 6 and 7 is for read and write the signal. Pin number 18 and 19 are connected to the crystal. So pin number 20 is connected to the ground, 40 is for VCC, and the most important pins are EA and PSEN. EA means external access. If EA is connected to the low, so this means external ROM will be used. If EA is connected to the VCC, this means internal ROM of 4 kilobyte will be used. After 4 kilobyte, 60 kilobyte will be connected externally. PSEN is program store enabled. When this is connected to the low, this means external ROM is used. When this is 1, external RAM is used. This is again the pin diagram. Port 0, port 1, port 2, port 3. Control functions are given, and these are the crystals. Crystal is connected, which will produce the frequency. Most of the cases, 12 megahertz or 11.059 megahertz will be used for 8051. So this was a pin diagram. Then there is an architecture. So architecture tells how this 8051 behaves, right? This is a ALU. We know that 8051 is having a 8-bit ALU. ALU is arithmetic and logic unit. Okay, so this is a basically CPU where the processing has to be done. So data on which processing is done will be stored into the A and B register. After the processing, result will be stored into the A is called accumulator. It will be accumulating the data. Whereas the status will be updated in a flag register of program status word. This is a 8-bit flag register and will store the status of the result, right? So then we are having an internal RAM and ROM. Internal RAM size is of 128 bytes. Internal ROM is of 4 kilobytes. PC and DPTR stores the 16-bit address. PC is a program counter. It stores the address of next instruction to be executed, where DPTR stores the address of the memory location from where the data has to be fetched. So DPTR is a 16-bit. It will store the address of 16-bit, right? So this latch will store the binary bits which has to be transmitted on each pin of port 0 and port 1, port 2 and port 3. So latch basically is used to give a delay the data which has to be transmitted on the pins of ports, right? And these ports alternate functions we have already discussed and is given here. Then we have to study memory organization. So memory organization tells how this memory is organized, right? So as we know, the RAM is of 128 byte. So data has to be fetched from this data memory. Then the processing is done and the result will be stored into the accumulator. Now we have to study how this memory organization works. So if we see RAM sizes of 128 bytes, so RAM is divided into the 3 parts, right? So if it is of 128 bytes, 2 raised to 7 is equal to 128 byte, but processor is of 8-bit, right? So for 8-bit, this means starting from the least significant bit, 7 bits will give the address of 128 byte internal RAM. So where lowest address formed is 00H and the maximum address is 01111111, which is 7FH, right? So RAM is divided into the 3 parts: register bank, bit addressable area, then scratchpad area. Bank register bank, there are 4 register bank. Each bank is having a 32 register and each register is of 8 bits. So 4 into 8 means 32 locations are reserved for register bank. This bit addressable area will be using 16 location. So this is 16 locations are there. 16 into 8 means 128 bits can be addressed separately. Scratchpad area is the general purpose memory area. So this is the byte addressable area where the byte of data will be addressed. So now if we see the register bank, there are 4 register banks, then bit addressable, 16 bytes, then general purpose RAM. Each bank is of having a 8 register. So this is 8 bytes. 8 into 4 will be 32 bytes will be taken by the register bank only. So for bit addressable, 2220F is reserved for bit addressable. Bit addressable addresses 00 to 7F. Right? So this means each individual address can be accessed. Individual address. Right? So individual bit means what? This bits will be 0 or 1. Then scratchpad is used for general purpose memory. Then if processor is 8 bit, then next address, which is 128 byte, 80 to FF is reserved for SFR. SFR is special function register. So this means this portion of memory will be used only for specific task or used as a special function register. These registers will be used as a program status word, stack pointer, ports, timer, serial control, power control, right, registers and accumulator. So this will be used for any specific purpose. So if we see SFR, so all the addresses will be reserved for any specific task, right? So what are these specific functions? Like 80H is reserved, used as a port number 0, whereas 90 will be reserved for port number 1, A0 port 2, B0 port 3. So these addresses are fixed. If I write move accumulator, comma, P0, so this means P0 content will be moved to the accumulator. But if I write move accumulator, comma, 80H, so this is the same. So this means the content of 80H will be moved to the accumulator. So I can write the address or I can write the direct port. Now, so this is the memory organization of RAM. We know from 00 to 7FH is reserved for the 128 byte of internal data memory, where 80 to FF is reserved for SFR. External memory is of 64 bytes. For 64 byte, address will be 0000H to FFFFH, right? So then we have to study the ROM. We know internal ROM is 4 kilobytes, right? So for 4 kilobyte, 2 raised to power 2 is 4. Kilo means 2 raised to power 10. It will be is equal to 2 raised to power 12. So this means starting from least significant, 12 only bits will be giving the address, right? And last nibble will be 0. So lowest address is 0000H and maximum is 0FFFH. Okay? So internal ROM is 4 kilobytes 00000FFF. Now, so this is an external access pin which we have discussed. If it is connected to the ground, so this means only external ROM is used. But if it is connected to the VCC high, so this means 4 kilobyte of internal ROM is used. After 4 kilobyte, yani ki 0FFF, from 1000 to FFF, external ROM will be used, which is 60 kilobytes. Clear? So this was the memory organization. So in memory organization, we have studied the RAM and the ROM. RAM is a data memory and ROM is a program memory. Then we have to study the program status word. Program status word is a 8-bit register flag and is used to store the status of result which will be stored into the accumulator. And the processing will be done in ALU. After the processing, status will be updated in PSW. So this is program status word and this is the flag register, is having a 8-bit and each individual bit is accessed, right? After the processing, if we see there is a carry from MSB, this may be addition process, so after, if we see whenever processing is done, has to be done on 2 numbers. If there is any carry from most significant bit, so this means carry flag will be 1. And if there is a carry from lower nibble to higher nibble, auxiliary carry will be 1. F0 is user defined. This user has to select this bit according to the requirement. RS1 and RS0 is register select, right? So this will decide which bank has to used. If this is 00, bank 0, 01, bank 1, 10, bank 2, for 11, bank 3. Then there is a parity flag. Parity is used to give which parity is used, even or odd. If number of ones are even, parity will be 0. If number of ones are odd, parity will be odd. Okay. Then there is OV. OV is overflow flag. If we see result is out of range, then overflow flag will be 1. So now for overflow flag, we have to understand the numbers. For unsigned numbers, we know that 2 raised to power 8 is 256 and its range is from 2 raised to power 255 or in hexa 00FF. If the result is out of range, यानी कि 000 to FF से बाहर है, तो इसका मतलब overflow flag will be 1. But if the numbers are signed number, for signed number range is minus 128 to 127. So this means overflow flag is 1. So we have to see if it is out of range, overflow flag will be 1. Right? So we have studied the PSW. Hope you have understood these topics. So thank you so much, everyone.